Thank you, Ping.
Okay, so you have you looked into the code yet?
Yes, Ping. I have looked at it, but I ask you, I don't understand some like the first line like I have need to math like math the data like the size 60 and 34 like this. And when I look at your data, like uh, it seems like 60 multiply 34 multiply 365.
Okay, so is
Yes,
the example file is just 1 year. So in the line number 5, the fifth line,
yes,
so it's the length of the year, right? So in this case, we have to prepare observation data and GSM data, both like start from 1985 until 2014.
yes. Mm.
So like we prepare a lot of file. So this we will use to create the what's it called? The functions of to bias corrected. This depend on your data range. So in my case I use 30 year, right? Yeah, it's a
Yes.
30 year
Uh,
data.
from from my observation data is from 1985 to 2011.
Okay, so that change to 2011.
Yes.
And what about the format? Can you create this format, the input format?
Um, the import format like this, right? I
Yes.
I cannot create it
Okay, let me show my
because
screen.
I don't understand.
I see. Uh,
I will stop
okay.
share.
So it should be same as your data that you show me. So if I sum total number of data, it will show like this.
Yes, please.
Or but if I show just only one, because it's daily data, so they sometimes they don't always have the rainfall data. Right. So this equal to like a latitude, longitude, something is cover the is like is the surface area of the rainfall, and the third dimension is the day number. Okay.
Yes,
The
yes,
number one is equal to the 1st January of that year.
yes.
In this case, it just look like this, which is somehow don't understand.
Mm.
So that's why I will show into some. So to create this one, we need to look back into your data first. Which format do you have? Or you have just the point stations? So this
Yes,
script
I can.
is not depend on the spatial rainfall. We can adapt it into the like, the stations number. Like if we have the stations number go to 10 with maybe just try 10. Let me think. I see. If we have the 10 number of observations and 10 grid of GSM, but we still need to prepare it to the annual data anyway. So if we want to create the same format that we could use for the input, let's try random number. The stations, one column and the size should be like this. It means that when this script do the batch corrections, it will consider just only 10 number of data, right? 10
It
row
means that
and
10
one column.
station.
Just 10 point of the data. Yeah.
Yes.
The third dimension always time.
Yes.
So we could do this. But in my case, is a partial rainfall, so it have another dimensions. So in this case, if we do the one Java station, we need to hand changing this. Just these two number, because this always fixed. Oh, okay, this one too. It is G number. In your case is like 25,
2011.
20,
Number here 27.
so
27 year.
should be maths. This is just auto calculations. So y number must be 27. I didn't change for this one. So this always the hand changing. And the number of days is always 31. The script be automatically assigned in a different number of months. Like January have the 31 day or February 28 day. They will assign for the best correction because this will separate. This script will separate the months. Like when this script do the batch corrections, it will separate into the 12 functions in each month. So that's why I have to divide the parameter. So like the data that in the January, we choose the function of January or February, March. I can't remember what this is for. Just make sure. Oh, okay. This is just reassign the data. This two line is one.
No data.
This is observations, and this one is GCM in this format
Yes.
or this format. So I always have another folder that store this data. So in this part is just prepare the data, prepare the input data, and then just do the bias corrections. And this one will reformat again and save the output as the same format here. So the short code of the bias correction is in the subfunctions. EQM sub1 and sub2. Okay. So the script will pass every data that necessary for create the time mapping functions here. Okay, using the ECDF command. this set will do the bias correction. The actual one occur here,
Yes.
just two line here. Then this is the output. Oh, sorry. The some I think this one is already modified. There are functions inside this function. So this sub to EQM will call this three line, which is same as these functions. So just don't need this one. This will pass the three data. This one is the functions of observation and GSM. So this is the data that we need to bias collected. So if we put, I didn't create form like the purpose of this script is just use all the data here to a function and bias correction all the data in this range.
Yes.
So then just okay, just now we can go back to your problem first. So you want to create this
Yes, I want
this format, right?
but I'm I'm not clear about this format. Like the first is row, like the station that I have.
So you have the station and or the spatial rainfall.
I have at the station, like observation. I have as a station, and for the GTM, I have it as a special.
So the problem is how to best correct that with the spatial rainfall with the point rainfall, right?
Yes.
So you have the spatial rainfall of GCM and point data of observation.
I already match like match it with the point with the grid already. Like the station in the grid, I like group it, not group it, like I note it in that grid.
Okay, I understand that.
Yes.
So it's like you matching the grid with the
Yes.
point data.
Yes.
So if just wait a bit. Which one?
Mhm.
I didn't have the grid. What? Okay.
Like if station.
Yeah. I think I create some map that contain grid and point.
Yes.
This one? Okay. So assume this is your GSM grid.
Yes.
I think we use the same data set, NASA GDTP, NASA something.
Yes.
0.25 degree GSM downscale from the raw one using the BCSD method. Okay. This point is not the rainfall station, but let us assume it just now is a observation data and a grid.
Yes.
So like you have, for example, we have this one
Yes.
this data here, then you just pick this cell, right?
Yes.
So total you have 8 cells that have the observation data.
Yes.
And what happened to the rest? How do you plan to correct the rest? The other cell that the other 3 cells that didn't have the stations.
The cell that then has station after my correction, I will interpolate it
So interpret before or after the best corrections.
after.
So it mean that you will extract the data like this point and this grid cell, right? So like you have the X stations.
Yes.
So the data should look like this one, right? 8 by 1 by 365, and another 5 for GCM must be look like same as this one, the same size.
Yes.
Hmm, hmm. Okay, so that look just fine. So the result will be same as this one. But to create this file, uh, the easiest way I think is maybe from the Excel or something. You have
Eight. Eight
eight
station.
column
Yes.
of 365. Yeah, observations and EQM. Let's just make it to a different number. Oh, oh. So the PR, LS read the sheet number 1 and ECM sheet number. Uh, okay, then just change the format. Let me find the format for a second. relocate the uh, forgot the command. Okay, it's not reshape. Yeah, I forgot the command, so just hand. So prepare the input first, then reshape it. Like just create the empty array of GCM. So in our case, in 8 by 1 by 365, then in MATLAB, we can just change the dimensions of the variable. Like we change, this is row and column, right?
Yes.
So we can change the column into row and this one into the third dimensions.
Yes.
They are one command, but I cannot remember. So then just for using it by hand, maybe just fine. Yeah. Alright. One, two, PR. Just swap the definition. Okay, should be the inside must be same. I think PR 128, and when I read something wrong here. Hmm. The first row. Okay. Oh, okay, I see. Mm. Let's check one. So when stations, just checking that the rearrange is correct. So exact the ones, the station number one with all the time range to be all equal to 1. And what about number 5? Should be equal to 5. And no, oh, I see. This one should be I, not 1. Okay, okay. This is too promising. Okay, using like this kind of preparations, So you just extract the observations and GSM at the same positions into the Excel file or different format. So each file should contain just 365 or 366, depend on year. And reshape it from this format. If we loading here, 365 row by 8 column into this format,
Yes.
8 by 1 by 365, and just change the file name and these two, row and column number.
Yes.
Or I will just update here and give it to you a new one that we don't need to change inside script a lot, because you need to dig through every line to change the number correctly if I didn't prepare. So if you change like this, you just concern only the first part. The let's just run through it normally. Okay, done. So you will change the output name. Yeah, something.
Yes.
Because I use the ensemble mean to test it, so I use the ensemble mean batch collection year and mat file. And this is the what it's called, the variable name. You can change it to anything you want. This in this case you need to change in 3 line. In MVC in line 58, 62, and this one. It's a string to write out, but it will use this variable. So after we finish this, I'll give to you this version, which is more friendly, I think. Normally I use it for myself, so I understand which part and which part. So this script is, we can change the method of the batch collections. This one just use the EQM. So you have your module, something like a linear scaling or gamma, just plug it here. Because this script is just main command to load the data and prepare the data.
Yes. Yes.
Then prepare everything, do batch collections. But first, before do batch collection, they will create the functions first using something. If we change the this command ECDF, empirical CDF, to like a linear scaling. So you know linear scaling, right?
Yes.
Just use the ratio to multiply the GSM data. So it is in similar idea. Create the functions or in case of linear scaling, just create the what you call multiply factor or the ratio or whatever the name, and just multiply back to the raw data. And here we change the value using these two lines. So this script is okay. I need to write something. Pin. So the functions of ECF may be like this. Okay, let's see the example. And third line. It's wrong way, but something like this. Something like this. Let's say one line is we observe rainfall, and this one is GCM. The number here maybe 0.1, the probability to 1. This is, and this is PR, rainfall. When we do the quantile, empirical quantile mapping, we did not fit into any distributions that assume it as they are. And if we want to do best correction on this value, right? We read this value of GSM probability first here. Am I correct? Maybe yes.
Yes.
I forgot the basic here. So it just shift it to shift the amount of the rainfall from the same probability, right? Probability density function something. Let's say it's yeah. Change the value of the GCM from this one to this one, right? So, but before we create this one, the data is come from many points. So to collect the rainfall, we not always know the every value of every probability. So let's assume that this one is P equal to let's say 0.6. But for the observations, we don't have the 0.6. Maybe we have a 0.5 59 and 0.62. So to matching it, right? We don't know the value of observation at the probability of 0.6. So we need the value between these two. So in my script, it used just linear interpolations between two dots. Can I assume that linear interpolations. So like we know these three values. So they do the linear interpolation to get the rainfall. The linear interpolation is come from this command, inter p1q. As I remember, it's a function within the MATLAB. Yeah, quick run the linear interpolations, which is work very well with this EQM method. So you can learn it more. Just use the documentations in the MATLAB. Try to understand what this script doing. But all in all, it's just the concept just here. And this one group is just for 1 month. I got April or something. So 12 months, 2 graph, 12 functions.
Well, graph.
Is do the bias correction separately in each month.
Yes.
So do you understand more? But first, let's try. You can try making this variable first
Yes, please.
to get the input. Then have anything else?
For me, not yet. I will try to prepare the data first, and then I try to run that code. If any question, I will ask you again.
Okay, when you finish the doing this part, you
Yes.
can do like a just plot the graph, right? Like compare like a before and after. Before